Hello students, welcome to the class. This is Mohan Raj, your trainer, and this is Genesis training. As we have seen in the last videos, we have seen speed maths concepts like multiplication by base method, and then we saw multiplication by Vedic maths method, and also we saw another video on addition subtraction shortcuts, right? So hope you have understood that and practiced the question which I gave you. So today we have another topic on speed maths, that is squares, finding squares of any number, how to get it faster and easy. Okay, so let us get into the topic directly without wasting much of time. First, before getting into the concept, we should learn the squares till 30. So you can look at this table which has squares till 30, and it's very important to learn this. Just like multiplication table, we should remember the values of these squares. So you can just observe all the squares. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and then 10 square is 100. 11, 121, 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square is 256, 17 square is 289, 18 square is 324, 19 square is 361, and 20 square is 400. Similarly, we have 21 square is 441, 22 square is 484, 23 square is 529, and 24 square is 576, 25 square is 625, 26 square is 676, 27 square is 729, and 28 square is 784, 29 square is 841, and 30 square is 900. So this is compulsory, because only if you know this, I can use the shortcuts for further. At least till 25 square you should know, and it's not a big deal to learn till 30 square. So please try to remember this. Okay, so let's go to the techniques now. So before getting into the actual formula or method, we have to learn how to find squares of the numbers which are ending with 5. Let's see that. So as we have observed, 5 square is 25. Right? So 25 square is, observe the way I am writing. First I write 25 and the remaining number is 6. 35 square will end with 25 again, and the remaining number is 1, 2, that is 12. 45 square will be ending with 25 only, the remaining digits are 20. 55 square is equal to 25, it will end with 25 only, but remaining number is 30. So you need to observe what I am doing. Okay, so we know that all these numbers are going to end with 25 only. Okay, any number square which is ending with 5, its square will end with 25 for sure. And the remaining numbers we need to understand. I got 6. What did I get 6? There is 2 here. 2 into the next consecutive number. 2 into 2 plus 1, that is 3. 6, that is the 6 here. So 3 into next number 4, 12. So that is 12. So 4 into 5 is 20. So in the same way I can say now 65 square will end with 25. So 6 into 7, 42. 75 square will also end with 25. And 7 into the next number 8. 7 8s are 56. 85 square will end with 25. And 8 into 9 is 72. So 95 square will end with 25. So 9 into next number 10 is 90. Right? So if somebody is asking you find out 155 square, no need to panic. It's going to end with 25 for sure. The next number here we have is 15. 15 into consecutive number 16. What is 15 into 16? We don't know 15 into 16, but we know 15 into 8. 15 into 8 is 120. As 16 is double of 8, our answer will be double of the answer, 240. So this will be 24025. So this is how we get any number ending with 5. Its square is always easy. Now we have understood squares till 30, and also we know how to find square of a number which is ending with 5. Okay. So let us use this, the knowledge which we have right now, to get the square of any other number. Let's start with the example 53 square. Okay. So we know our nearest number to this 50 square. Okay. I call this 50 as a base now. Okay. So now I'm going to find 53 square. As 53 is more than 50, we are going to write 50 square plus something. Okay, so the base is 50, the given number is 3. What is the difference between the base and the number, the deviation? So deviation is 3 into the base and the number given. Let's see what is this. 50 square is 2500 for sure, right? And 3 into this is going to be 103. So what I am getting is 2500 plus 309. So my answer is going to be 2809. So let us check the next example then. Let us check this next example. The next example what we have is 84 square. Let's see what happens with the 84 square. And you can tell me now what is the nearest base. The number which is near to 84, and it has to be, whose square has to be known to us. You can take 80 as a base, or you can also take 85 as a base. Now I'm going to take 85 as a base. 84 square I want. Obviously 84 square will be less than 85 square, so I need to write minus, and the difference between them is 1 into 84 plus 85. Okay, so 85 square you know already, 8 9s are 72 followed by 2 5 minus this sum which is 169. So how will you subtract? Subtraction I told you, subtract from the left side only. 72 minus 1 I could have done, but next 25 minus 69 is not possible. I borrow, so 71 minus 1 is 70. I have 12. In the 12 also I need to borrow 1 here. It's 11 minus 6, 5. And I have 15 minus 9, 6. 7056. And this number is 4. Its square should end with 6 only. Right? So I can do the same thing with 80 as a base. 80 square plus 4 into 80 plus 84. So then what happens? 6400 plus 4 into 164. So I got 6400 and 1640 is 640 and then one more 16. So when you solve this, your answer will not change, you will get the same answer. But for me, the base is the most nearest number. I took the base as 85. You can also take base as 80. You can also take base as 75. But which is more nearby will give less calculation. See here, it was only 2 numbers to subtract. Okay, here you have to multiply and then add everything. But the answer is going to be same. If you do the calculations correctly, the answer is going to be same. Let us take one more example and then I'll derive the formula. The next example is 92. So what is the base you're going to consider for 92? For 92, I can take base as 90 itself. That is the best one. So you can even try 95. But compared to 95 and 90, the better one, first of all, 90 is ending with 0. Second thing, 90 is more nearer to 92 than 95. So logically, we are going to take 90 as a base. Okay, 92 square is 90 square plus the difference between 92 and 90 is 2, and then 90 plus 92. So the answer is 8100 plus 2 times 182. So what I am going to do is 8100, 2 times 182 is 364. Right? So the answer is going to be 8464. 8464. This is going to be our 92 square. So now we have to observe what we did. So we have written plus if the base is less than the number. In the previous example 84, I took 85 as a base where base was more than number, so I wrote minus. So in general the formula can be like this. If n is the number whose square we are finding and b is the base next to that. So if base is less than the number, then we go for square of the base plus the deviation b minus n into the sum of the numbers. If the base is more than the given number, then we have to subtract. Obviously it doesn't make sense to add more than the number, so we have to subtract. Nothing else will change. So that is why in general I have written plus or minus. So if it is base is less than the number, we put plus. If the base is more than number, we need to subtract, so minus. So using this formula, we can find square of the numbers when we get the base. Let's see another example here. I have 83 square now. 83 square can be written as 85 square minus 2 into 83 plus 85. So what I get here is again 85 square we know already, 7225 minus 2 times, this is going to be 168. So when you multiply 168 into 2, which is going to be 336, we have to subtract 336 from our 7225. Again 72 I cannot do, I need to borrow 1 from 25. So I will go for 71 minus 3 is 68. Okay, so now we have 12. In the 12 again I have to borrow 1. It is 11 minus 3, 8. And then 15 minus 6 is 9. So our answer is 6889. So using that formula. So the same formula, it's coming here. This is the formula. Okay. So next I'm going to remove this and try the next example. The next example is 97. So 97, which is the nearest base? You can take 95. If to avoid subtraction, you can try 95. Or if you are fine with the subtraction, you can go for 100 also. I'll go for 95 only now. 97 square is equal to 95 square plus 2 into 95 plus 97. 95 square is obviously 9025, 9 into 10, 2090 plus 2 times this 5 plus 7 is 12 and 180 plus 12 is 192. So what is the product of 2 into 192? It is 384. So we are going to add this way. It's addition now. So it's going to be 9409. This is the square of 97. Let's try one more example with this, and then we are going to go for the next method, which is universal method. 44 square can be written as 45 square minus 1 into 45 plus 44. Base is 45, the number is 44. So 45 square, for 4 5s are 20, 25 minus this sum is 89. You have to remove 89 from 20, 25. From 20 I need to borrow 1, it is 19. And 12 minus 8 is 4, again I have to borrow 1. 11 minus 8 is 3. I end up with 15 minus 9, 6. The answer is 1936. Square of 44 is 1936. Hope this is clear. Let us get to the another method which will be easy for us in every case, whether we know the base or not. Before that, we have to solve these examples again with our method. 36 square can be written as 35 square plus the difference is 1. See the formula, and 35 plus 36. What we get here is 1225 plus we have 71. So we need to add this. It is very simple to add them. Directly I can say 1296. Right? 52 square, obviously you will consider the base as 50 only. That is the best option to take, into 50 plus 52. So what happens to this is 2500 plus 2 times 102, which is 204. We are going to add 204 to 2500, which can be done in mind only. It is 2704. Right? So we are going to erase this all again, and then we are going to find the square of 73 square. You can try 75 this time. It's your choice now, whichever is easy for you. The difference is 2, and then 73 plus 75. In the bracket it is always plus base and the number, right? So we have 75 square means 5625, because 7 8s are 56, minus 2 times 148. So 2 times 148, you have to imagine what is the double of 148, which is actually 296. We are going to subtract that. Okay, in order to avoid subtraction, you can go for always the base less than the number. You could have taken 70 as a base also. Right? In the 56, I have to remove 2, but before that, I need to look at 25. 25 cannot remove 96. I borrow. So 55 minus 2 is 53. And then we have 12. In the 12 again, I borrow 1. So 11 minus 9 is 2. And 15 minus 6 is 9. So the answer is 5329. Right? Now let us see, is there any other method better than this to avoid all this calculation, or much calculations can be avoided or not. Let us see. This is the method. I call this as a universal method. Why it is called universal method? Because whether you know the number near to that whose square, you know that or not, doesn't matter. If you know the basic square till 30, you can answer this question. And this identity is known to everybody, that is a plus b or minus b whole square will be equal to a square plus b square plus or minus 2ab. So using this, we are going to solve the questions. Right? Let's see what we have in the example. Square of 89 they are asking. So using this method, how are we going to get the answer of 89 square? 89 square can be written as 90 minus 1 whole square. So according to our expansion, our answer will be 90 square plus 1 square minus 2 into 90 into 1. So which is 90 square, everybody knows 81 square 100 plus 1 minus 2 into 90 is 180. What I am going to do is, I am going to subtract, the sum of this is 8101 minus 180. Right? So when you are subtracting 81 minus 1, I could have done, but I cannot remove 8 from 0. So I borrow 1. 80 minus 1 is 79. Now I have 10. 10 minus 8 is 2. And then 1 minus 0 is 1. And remember, the number is ending with 9. Its square should always end with 1. So the answer might be right. Okay, if you verify with the calculator, you will get the same answer, 7921. Right? So let's go for the next example. The next example what we have is 106 square. To get square of 106 square, so I am going to go for 100 plus 6 whole square, a plus b whole square. What is the expansion of this? 100 square plus 6 square plus 2 into 100 into 6. Right? So 100 square is 1 followed by 4 zeros plus 36 plus 2 into 100, 200. 200 into 6 is 1200. So what I am going to do is 10,000 plus 1000 is 11,000. Added the thousands and hundreds, there is only 200, and then we have 36. So the answer is 11,236. That is the square of this number. Let's go to the next example. Here only. What is that? 69 square. I can go for 65 plus 4 whole square, or I can go for 60 plus 9 whole square, or 70 minus 1 whole square. In this case, 70 minus 1 is better deal. It's because it's only 1, so I can easily do that. 70 square plus 1 square minus 2 into 70 into 1. See, the number becomes very easy. 4,900 plus 1 minus 140. So I am going to write it one below the other for us to subtract easily. 140. So again 49 minus 1 I don't want to do because I need to borrow 1. So it will become 48 minus 1, 47. And 10 minus 4 is 6. And we have 1 here. Again the number is ending with 9. Its square is ending with 1. So no need to worry. Hope this is clear for you. Let's try some bigger numbers here. And I need to tell you one important thing. Any 2-digit square will give you either 3-digit or 4-digit based on the value of the number. If the value is very small, less than 50, it might give you 3-digit. For example, 25 square is giving you 625. Whereas our 75 square will give you 5625, 4-digit, because the number is bigger, very much far from 50. Right? So similarly, For a 3-digit square, if you square the number, if the smaller the number, we get 5-digit in the place, or we get 6-digit. So you should either get 6-digit or 5-digit. The number is very much bigger than 500, it will give you 6-digit. The number is less than 500, it might give you 5 digits. Let's see what is that. And we need to remember this kind of logic so that we don't make a mistake. 256 whole square asking. So a better deal is to go for 250 plus 6 whole square. 250 means for 250 whole square we can square it easily, and 6 square we can square it easily, and then we have to go for 2 into 250 into 6. What is 250 whole square? 25 square we know, 625 followed by 2 zeros. 6 square is everybody's aware of it, that is 36, and this is 2 into 250 500, 500 into 6 is 3000. Okay, now I have 60,000 plus 3000, I am going to write it as 63,000 directly, adding the thousands only, right? So 63,000 and then 100, there is only 100, 500 and then 36. So the answer is 63536. Make use of the techniques you learned in the addition subtraction concept, right? Adding the thousands only, 62,000 plus 3000. So there is a mistake here. 62 plus 3000 is 65,000. So it's going to be 65,536. Right? This is the final answer. Let's see. Next example, 152 whole square. Obviously, you are going to see this as 150 plus 2 whole square, which is again 150 whole square plus 2 square plus 2 into 150 into 2. So you can say 15 square, everyone knows 15 square is 225 followed by 2 zeros and plus 4 into 150 is 600. Again, how will you add this? 22,000 as it is, thousands, and 500 plus 600, 1100, and there is only 1 4 to add. So the answer is 23,104. This is the square of 152 square. Let's take last example in this, that is 601 whole square, which can be written as 600 plus 1 whole square. A plus b whole square expansion is 600 square plus 1 square plus 2 into 600 into 1. Very simple number. So 36 followed by 4 zeros plus we have 1 plus 1200. So we have 3 lakh as it is, right? And 60,000 plus 1000 is 61,000. Adding the thousands, adding the 100, only 200, and there is no 10, there is only 1. So if we add all this, we get 36,000, 3,61,201. It's a 6-digit number because the number is more than 500. So this is how we get the squares. So you can do it for even 4-digit numbers using this method. This method works everywhere. That is why it is called universal method. So let's come to the practice exercise. You have to find the squares of these following numbers. I have given only 8 numbers to calculate, but you can practice by taking your own numbers. Any number randomly you can take and practice and verify the answer with the calculator until you get the answer faster. Please practice it. So you need to get the answers within 30 seconds, 20 seconds. That is how you have to practice. So let us meet again in the next class where I am going to discuss about finding the cubes of a number. Some interesting methods are there in finding cubes also. Let us see that soon. Thank you so much.